Welcome back to the hyperbolic coding chamber. We are back once again. Had some difficulties today because my brain is scrambled from the jet lag. So yeah, so that's kind of where we're at. Hopefully we can fix the sleep schedule tonight and things will return to normal. But that being the case, we have a comment from a good friend of ours that we're going to take a look at. A comment from Sally Akramjoy, which is a legendary name, by the way, and an even cooler profile picture. How do you keep motivating yourself to solve LeetCode problems regularly? How to be more consistent in LeetCoding? I feel like there's a ton of better stuff on this by people like Colin Galen or Nick White, or I'm not sure if LeetCode ever talks about this or if he just makes regular like teaching videos, or if he never does like tips or anything like that, but I'm not exactly certain. I think I tried a bunch of things and some things stuck. One thing is to try to do it every day, but keep the bar for success really low. So you could try one way that I try to do it is to do it every day and then keep the bar really low. So I set like a minimum every day that like I would commit to do on my worst possible day. So that would be like when I first started, it was like 5 or 10 minutes. I think like on the worst possible day where you've worked for 16 hours and you got no sleep and something else happens in your personal life, how much would you willing to commit on that day? And I think I said like 5 or 10 minutes. That's what I did for like 70-ish days, and then the time slowly grew, and then now we're kind of at 30 minutes. I think we'll get back to an hour once the sleeping schedule becomes normal. Doing an hour every day without the sleep schedule being correct ends up pushing everything else back. So I think we're at 30 minutes for now. Even yesterday, you can tell I did like 24 minutes or 22 minutes. And I think what has definitely helped me is keeping the bar for success low. Even on yesterday when we have like tough days where the sessions are just shorter, I try not to feel too bad about them, and sometimes I have to like walk. Sometimes you do a recovery walk to keep running. So I would say that's how I did it. I don't know if there's a lot of motivation there. I think the process of showing up every day made it easier to get over the hump of, oh, I have to do LeetCode. Because after doing it for so long, you're just like, oh, I have to do LeetCode. So I think, I don't think the motivation increased. I guess I decreased how much mental barrier it took to start doing LeetCode. Now it feels more like brushing my teeth. Even though I'm dog at it, I guess showing up to do LeetCode feels like brushing my teeth, even though I'm dog at LeetCode itself. So it's kind of easier to just say, oh, I'm going to do LeetCode today, even though we're still doing easies and we're not doing a lot of crazy stuff. But I think the process of showing up became a lot easier, which has helped a lot in terms of doing other things too. So I would say work for me is doing it every day and keeping the bar for success really low, I would think. So maybe those would be helpful. So these helped me. Not sure if they will help you. Your mileage may vary. Do it every day to keep the bar for success really low. For me, the hardest part I realized was just starting. Yeah, so hopefully we'll get to a point where we have done all the problems. That future these days looks relatively bleak, but hopefully we get there. But we got to do a lot of problems yesterday. What's interesting is that my shorter sessions seem to have to do with solving, I don't know what it is. Yesterday we solved I think 3 or 4 problems in like 22 minutes. They were all easies though, and then I don't know what it was, but I was just like, this is not Flames. And since the lowest amount of time I think I ever said I would do is, I think the lowest time I ever said I would do is 15 minutes, because that's what I started with. Something just gets really hard about, I need to chew on the problem. And sometimes chewing on the problem is like the funnest part. But maybe the reason I'm stopping early is because I solved 3 or 4 problems, and now I think I have to continue the streak in which each problem I solve, I guess maybe I'm having some subconscious braking system where I'm afraid that if I go to the 5th problem, I won't solve it. But I don't know. So we'll see if we run into that again today, and if we don't, or even if we do, we're going to see if we can break past it and still do 30 minutes anyway. So that's where we're at. And yeah, thanks for the comments. Thanks for coming through. Thanks for all the people who joined the Discord. I'm a little low energy today because I'm jet lagged out of my mind, and my sleep schedule is on the other side of the planet. But we are here, and yeah, we'll just see how the session goes. So you are given a string, which is called number, representing a positive integer and a character digit. And a character digit. Return the resulting string. Return the resulting string after removing exactly 1 occurrence of digit from number, such that the value of the resulting string in decimal form is maximized. Test cases are generated such that digit occurs at least once in number. So we have 1, 2, 3, and digit is equal to 3. We have to remove 1 digit, at least 1 occurrence of digit, such that the number is larger than it would have been. So that the number would be maximized. There's only 1 3 you can remove here, so you just remove that. This case is also only one. There's a 1 that we can remove. We have 2 options, either the front or the end. If we remove from the end, we get 1, 2, 3. If we remove from the front, we get 2, 3, 1. We can remove the first one Then we have 5, 5, 1. We have 2 5s. We can remove any 5, and we'll get 51. Number.length is at least 2, so we're given at least a double-digit number, and number consists of digits from 1 to 9, so it's always a valid number. And digit is also always a valid number. Digit occurs at least once in number. So always have at least one thing to remove. I think one way you could break this down is another way we could reframe the question. What's the largest number out of the set of numbers where we remove from the number? So everywhere we find 1, we can basically just create a new a new number. So we can change it to, what if we generate all the numbers where 1 is missing? I think this would take at most n squared time. Oops, I shouldn't have looked at that. I think that at most this would take n squared time. So this is what we'll do to reframe the problem. We're pretty much gonna generate all numbers where at least 1 digit is missing, then take the max of those numbers. The way we can do this is by doing let I equals 0. We could iterate over all the numbers in number. Which is going to be a number array. We iterate over all the numbers until we find a 1. If we find a 1, we're going to iterate back all the way to the start and add all the numbers. While removing that 1 number. So to do that, we can say that I is less than number dot length. I plus plus. We'll say if number sub I equals digit, right? Then we want to say numbers, right? Dot push, and then here's where we can do number dot slice, right? We want to remove the index where I is at, and slice I think works exclusive of the end. So say 0 to I, right? Dot concat number dot slice numbers, or number dot slice I plus 1 to the end. Right, and then we can join the whole thing by spaces. I can't see the rest of my characters for some reason. I'm not understanding that slice 0 to I, concat number dot slice I plus 1. We say num r. I'm not. Why is this saying I can't join them? So I'm just gonna click run and then return an empty string just to see why this is some kind of type error or something. Oh, no, wait. Property joint is not exempt type string. It should be a string array. Do I have to say that it is? I see what's happening. I forgot number is an actual just string. We're just gonna spread it into an array. And we'll just call this num_r. The math.max of max num and num. This is actually called numbers. I think the part that's confusing about this problem is the variable names. And I think I got confused a couple times. I hope this works though. We didn't expect this. Yeah, the numbers can be quite large, so turning them into strings and turning them into numbers gets a little sticky because once we turn them out of numbers, it turns into nonsense. Could use a big int. A lot of type nonsense this time. Yeah, I guess even maybe that's too big for... I think we're losing precision. Another thing we can do, which is sort of ghetto, is we could keep this an array of strings. Instead of searching for the largest number, we'll just do numbers dot sort them as strings. No, numbers. Yeah, the variable names I chose for this problem are awful. Num_r, which represents what exactly? Let's just change this to candidates. I don't know if the sort is going to come out correct. So I'm thinking the answer we're looking for is at the end. We have a for loop, but the two slices is basically linear time. So this is basically n squared time, which is more than n log n. So I would say this takes n squared time. I think there's n squared time plus n log n, but n squared dominates, I think. Space would be linear space in the worst case. I feel like there's some. I was getting a greedy vibe from this problem. We checked the tags. There's a greedy vibe. There is some intuition I think we could take to the level that would give us the correct answer. There's a digit in the front. There's a digit at the end. Digit somewhere in the center. The digit somewhere in the center. If we had something like 1. 1. We have 3 candidates here. 414. Here we're the one at the front. End would be 1414. Middle would be 1441. We could take the front, the end, or the middle. What if we change the case to something like this instead, where it's 2 at the front? You would get 2141, and here it still makes sense to take the first one. Actually, you get 1214 if you take the front, and you would get you get 2141 if you took the front, and 1214 if you took the end. Digit in the front, digit at the end. Hmm. Yeah, I don't think I'm seeing the greedy solution. Maybe I need to look closer, but it seems like you can almost always take the front. Well, why could you almost always take the front? If the digit is large enough, if you take a digit from the end, everything slides down one. You take a digit from the front, everything slides down one still. But it's crazy how if you take one from the end here, you get 1, 2, 3. It seems like if the front and the end are the same, you should always take the front. So if the front and the end are the same, the next number that should come up one, two, three, one. Dang. That one makes sense. I guess that's the thing with stuff like this. After reading the solution, I really thought there was I thought about that route, but it seemed, I guess I got overwhelmed by the complexity of checking the strings. I didn't think we could just ignore the middle segment. But it do be like that, but I think that is okay. And we live to plug another day, so